Hello everyone and welcome to the lecture on Amazon Kinesis data streams. So this lecture will contain all these topics. What is Amazon Kinesis data streams? What can I do with Kinesis data streams? Kinesis data streams high level architecture, Kinesis data streams terminology, Amazon Kinesis data stream and shard, quotas and limits. So what is Amazon Kinesis data streams? Amazon Kinesis data streams is a service that allows you to handle massive amounts of data in real time. This capability is crucial for businesses that need to analyze and act on data as it is generated. These are custom applications you can develop to process the data from your streams. They form the core of your data processing pipeline, allowing you to transform, analyze, or aggregate your data as needed. The Kinesis Client Library (KCL) is a software development kit that simplifies the process of building Kinesis data streams applications. It handles many of the complex tasks associated with distributed computing, allowing developers to focus on application logic. Kinesis data streams applications can be deployed on Amazon EC2 instances. This provides a scalable and flexible environment for running your data processing workloads. A typical Kinesis data streams application reads data from a stream in the form of data records. This allows for continuous processing of incoming data, enabling real-time analytics and decision making. After processing, the data can be used in various ways, something like sent to dashboards for visualization. You can generate alerts based on certain conditions. You can dynamically adjust pricing and advertising strategies. You can integrate with other AWS services for further processing or storage. So what can I do with Amazon Kinesis data stream? So Kinesis data streams enable fast and uninterrupted collection and combination of data from various sources, allowing businesses to process information as it arrives. Kinesis data streams can work with a wide range of data, including IT infrastructure logs, application logs, social media content, market data feeds, and web clickstream data. This versatility makes it suitable for many different industries and use cases. Because Kinesis data streams process data in real time, it typically uses lightweight processing methods. This approach allows for quick response times and efficient handling of large data volumes. Producers can push data directly into a stream, making it available for processing within seconds. This feature prevents data loss in case of front-end or application server failures. Kinesis data streams does not batch data on servers before intake, leading to faster data feed processing. Kinesis data streams enables simple data analysis and reporting in real time. For example, you can process metrics and generate reports for system and application logs as the data streams in, rather than waiting for batch data. This use case combines parallel processing power with real-time data analysis. For instance, you can process web click streams in real time and analyze site usability engagement using multiple Kinesis data streams application running simultaneously. Kinesis data streams allows the creation of directed acyclic graphs (DAGs) of applications and data streams. This advanced feature enables complex processing scenarios where data from multiple Kinesis data streams applications can be fed into another stream for further processing by different application. So this is the high level architecture of Kinesis data stream. So you have the producers continuously push data to Kinesis data stream. So these producers can be EC2 instances, client, mobile client, or traditional servers. They will be pushing data continuously to Kinesis data stream service. And the consumers process the data in real time. So these are the consumers which are developed using, they are the KCL applications, Kinesis data stream application, using the Kinesis client library. Consumers and this process in real time, and then so it can actually store it by after doing some processing. It can be written to DynamoDB, it can be loaded into Redshift, or it can be further processed with Amazon EMR. And the consumers such as custom applications which are running on EC2 or an Amazon data firehose delivery stream. So it can be this, or it can be data firehose. So it can stream to data firehose, and from data firehose you can set up to some destination target. So these two scenarios are possible. and you can store their results into various services. So this is how a typical high level architecture of how we use Kinesis data streams in production or in real world. So now I'll just cover the Kinesis data stream, all the terminology associated with data streams. So first we know Kinesis data stream, which is a set of shards. So a Kinesis data stream is a set of shards. Each shard has a sequence of data records. Each data record has a sequence number that is assigned by the Kinesis data stream. Then you have data record. A data record is the unit of data stored in Kinesis data stream. Data records are composed of a sequence number, a partition key, and a data blob, which is an immutable sequence of bytes. Kinesis data streams does not inspect, interpret, or change the data in the blob in any way. Our data blob can be up to 1 MB, 1 megabyte. And capacity mode. Our data stream capacity mode determines how capacity is managed and how you are charged for the usage of your data stream. Currently, in Kinesis data streams, you can choose between on-demand mode and a provisioned mode for your data streams. With the on-demand mode, Kinesis data streams automatically manage these shards in order to provide the necessary throughput. You are charged only for the actual throughput that you use, and Kinesis data streams automatically accommodate your workloads accommodates your workloads throughput needs as they ramp up or down. But with provision mode, you must specify the number of shards for the data stream. The total capacity of a data stream is the sum of the capacities of its shards. You can increase or decrease the number of shards in a data stream as needed, and you are charged for the number of shards at an hourly rate. Next is retention period. The retention period is the length of time the data records are accessible after they are added to the stream. A stream's retention period is set to a default of 24 hours after creation. You can increase the retention period up to 8,760 hours, which is 365 days, using the increase stream retention period operation, and decrease the retention period down to a minimum of 24 hours using the decrease stream retention period operation. Additional charges apply for streams with a retention period set to more than 24 hours. Next is producer. Producers put records into Amazon Kinesis data streams. For example, a web server sending log data to a stream is a producer. Then consumer gets record from Kinesis data streams and process them. These consumers are known as Kinesis data streams application. Amazon Kinesis data streams application. An Amazon Kinesis data streams application is a consumer of a stream that commonly runs on a fleet of EC2 instances. There are two types of consumers that you can develop. One is shared fan-out consumers and enhanced fan-out consumers. The output of a Kinesis data streams application can be input for another stream, enabling you to create complex topologies that process data in real time. An application can also send data to a variety of other AWS services. There can be multiple applications for one stream, and each application can consume data from the stream independently and concurrently. A shard. A shard is a uniquely identified sequence of data records in a stream. A stream is composed of one or more shards, each of which provides a fixed unit of capacity. Each shard can support up to 5 transactions per second for reads, up to a maximum total data read rate of 2 MB per second, and up to 1000 records per second for writes, up to a maximum total data write of 1 MB per second, including partition keys. Okay, so the data capacity of your stream is a function of the number of shards that you specify for the stream. The total capacity of the stream is the sum of capacity of its shards. If your data rate increases, you can increase or decrease the number of shards allocated to your stream. Next is partition key. A partition key is used to group data by shard within a stream. Kinesis data streams segregates the data records belonging to a stream into multiple shards. It uses the partition key that is associated with each data record to determine which shard a given data record belongs to. Partition keys are Unicode strings with a minimum length limit of 256 characters for each key. An MD5 hash function is used to map partition keys to 128-bit integer values and to map associated data records to shards using the hash key ranges of the shards. When an application puts data into a stream, it must specify a partition key. So this is how you will, so that it gets evenly distributed to, let's say you have 3 shards and a Kinesis data stream. So the way it will calculate, you will have partition key and then it will calculate the MD5 hash so that it gets evenly distributed. Otherwise, for example, if it doesn't do the like a hash, it may get to a single shard, and that you can have a hot spotting. Like a single shard will have more data and other 2 shards will have less data. So this is how it will make sure that it gets evenly distributed among the number of shards that you have. Then you have sequence number. Each data record has a sequence number that is unique per partition key within its shard. So Kinesis data streams assigns the sequence number after you write to the stream with client put records or client put record. Sequence number for the same partition key generally increases over time. The longer the time period between write request, the larger the sequence number becomes. Then we have Kinesis client library. A Kinesis client library is compiled into your application to enable fault-tolerant consumption of data from the stream. The Kinesis client library ensures that for every shard, there is a record processor running and processing that shard. The library also simplifies reading data from the stream. The Kinesis client library uses an Amazon DynamoDB table to store control data. It creates one table per application that is processing data. And then application name. The name of an Amazon Kinesis data streams application identifies the application. If each of your applications must have a unique name that is scoped to the AWS account and the region used by the application. This name is used as a name for the control table in Amazon DynamoDB and the namespace for the Amazon CloudWatch matrix. And then you have server-side encryption. So Kinesis data streams automatically encrypt all your sensitive data, which gets stored, or whichever you as soon as producer puts a record, you will have automatic encryption of all your data and data records. Okay, these are some of the Kinesis data stream and shard quotas and the limit. So you have 2 mode, as I talked about. You have on-demand mode and you have provision mode. So number of data streams for the on-demand, default is 50 and can be increased via support ticket. There is no upper quota. For the provision mode, you can specify how much you feel like, how many number of data streams you want. So it's per account, per region. So data stream is the highest, right? So you will create a stream and you can have 50 streams, and every stream can have shards. So number of shards, there is no upper limit for the on-demand mode, and it automatically scales based on the volume and the traffic. For the provision mode, there is no upper limit. Default is you will have 500 shards, and for these 3 regions, and 200 shards for other regions, but it can be increased. This is for provision mode where you want to have more control. Next is data stream throughput. Default is for the on-demand 4 MB per second write, 8 MB per second read, which can scale up to 200 MB per second write. So your producers are pushing data, so this is writing, and 400 MB per second read. So consumers are reading data from the data stream, and it can be increased up to 2 GB per second write. So per second it's 2 GB per second, and read 4 GB per second via a support ticket. So you can see mostly as you observed, writing is always slower than reading, because reading is of course will be faster because you just read information. Writing means you have to do more hardware or whatever is the underlying technology. It has to do more work. For the provision mode, there is no upper limit. and depends on the number of shards. The throughput is directly depends on the number of shards. So each shard has a 1 MB per second capacity or 1000 records per second write. This is the capacity. For read, there are 2 MB per second read or 2000 records per second read capacity for each shard. So let's say you allocate for example 100 shards. So you can just do 100 shards into 1 MB. So you can have up to 1000 MB of write and 2000 MB of read. So you just allocate number of shards depending on your application. Then data payload size, you can have up to 1 MB. So one data record. So that is, we are talking about payload, a single payload. So a single payload can have up to 1 MB before base 64 encoding. So it will do base 64 encoding, the producers. So this is before. So up to 1 MB. And provision mode up to 1 MB. So same. So rest all is same. So I'll just talk about one side only. So get records transaction size. So you can have up to 10 MB or 10,000 records per call from a single shard. So this is for getting the record. And data read rate per shard. So max is 2 MB per second via get records. Number of registered consumers per data stream. You can have up to 20 registered consumers. So consumers are basically your the readers, right? And switching between modes. So you can switch from on demand to provision and provision to on demand. But you can do it only twice in every 2 hours. So this is the limit for the stream and shard. Okay. And that's all. Thanks for watching.